Assalamu alaikum dear students. I hope everybody is fine. I am Dr. ALEVELCAMS and you are watching YouTube channel ALEVELCAMS. In this lecture we will discuss about the geometrical illustration of the addition of two complex number and the subtraction of two complex number. In the previous lecture we did the addition and subtraction by the algebraic manipulation. But here we will see the geometric interpolation. It is very easy to visualize. Let's say this is real axis and it is imaginary axis. So consider this is a point P1 whose corresponding complex number is Z1. So let's say this is X1 and this is Y1. So it is Z1. And let me talk about the another complex number Z2. Let's say this is X2, it is Y2. So it will be Z2 complex number. And if we want to add them, so we can place Z2 here and the addition will be from origin to this one. This is Z2 and you can write here Z1 plus Z2. The addition of by head to tail, it is quite easy. Now we see about the subtraction. Let's say I am interested to find the subtraction Z1 minus Z2. So what will be its geometrical illustration? The Z2 with the negative, so we will change the sign, it will be here. So you can see that from this one minus Z2 and this is Z1, so you will have the complex number Z1 minus Z2. Understand? Let's say if you have two vectors Z1 and Z2, so it will make a parallelogram. So the main diagonal is Z1 plus Z2 and the off diagonal is Z1 minus Z2. So student, now we talk about some geometrical representation of the complex number. Let's say this is real axis, this is imaginary axis and this is a complex plane. Complex plane is nothing but the XY plane. Let's say I have Z equal to 2. It means you have here. But if I write down 2 iota, it means you will move over the imaginary number which is 2 iota. Whenever you have iota, you will be moved at here and you can see that the here angle is 0 and here angle is 90 degree. So iota angle must be at the 90 degree while the all real number, pure real number are lie on the real axis, so it has 0 angle. So student, we talk about the modulo of two complex numbers Z1 plus Z2. Let's say Z1 is complex number, Z2 is complex number. When we add them, it is again a complex number. So we take modulo of this one. So it is equal, less than equal Z1 absolute, Z2 modulo plus Z1 modulo. The proof is beyond your course, so you can skip it. But if you will request, I will make another video for you. So similarly, we can write Z1 minus Z2 is less than is equal to Z1 plus Z2 less than equal Z1 absolute, Z2 absolute. So you can see that G be a complex number, but the modulo is written as A square plus B square. So it is pure real number. Understand? Let's say there are two real numbers. So you can compare them. They can be equal. One number can be less than the other or one number can be the greater than the other. But for the two complex number, so you can understand that every complex number will be a point in a complex plane. Let's say we have 2 points. Let's say Z1 is this point, Z2 is this point. So which number is greater than the other number means this is a complex number, this is another complex number and this is the complex plane. So two number you cannot compare. We cannot have such possibility to compare. If you can see, these are two other locations. So we cannot say about one location is greater than the other or other location is less than or equal to the other. So it doesn't make sense. We can compare two complex numbers. So we have a comparison between the real numbers. We come to the question number 2. In question number 2, we have to represent the complex number Z and another complex number iota G whole conjugate. Let's say this is another complex number omega be another complex number. We have to represent on the same Argand diagram. What is Argand diagram? The geometrical representation or geometrical illustration of the complex number in a complex plane is called the Argand diagram. Argand is a mathematician who gives this notion that how we can visualize the complex number. After his this notion or this idea, the graphical representation is called the Argand diagram. Okay, let's say I have a vector v of some length v absolute. If I multiply this vector by 2, it means, let's say the vector v is this one, it will double the length. Understand? It means the value or the number that we multiply has a geometrical interpretation. So similarly, a little bit before I have tell you that when we will have a iota, it means we have to move at an angle 90 degree. So let's say g be a complex number with 2 minus 4. 1, 2, 3, 4, 1, 2. Let's say this one is complex number z. Understand? This is minus 4 and it is 2. If I take its rotation at 90 angle, maybe it will be go somewhere here. I have no idea where it will go. But if the number is on the real axis, I will move here. If here, I can move here. But if the number is here at the 90 angle, it will be where it will go. Immediately I cannot write, but by the value I can write. So let's say it is this one. We have to move this number. Let's say it will be here, and after that we have to take its conjugates, meaning we have to take reflection about the real axis x. So now we evaluate this number and see the exact diagram of this one. So it can be written as imply iota g is iota 2 minus 4 iota, which is iota square is minus 1, and this one 4 plus 2 iota. This is 3, 4 plus 2 iota, this one. Here is the number iota z. But when I take its conjugate, it will be 4 minus 2 iota, so you have here. So this is omega. This is your graphical representation illustration, which is known as the Argand diagram.